Stainless steel threads are failing under pressure. You're not alone. But the problem isn't your skill, it's your process. Day in and day out, machinists face three nightmares: excessive tool wear, unstable precision, and frustrating production bottlenecks. Today, we're cutting through the noise and giving you the ultimate guide, straight from the CNC workshop of LS Manufacturing. Why is stainless steel so difficult? First, it work-hardens. The surface becomes harder than the core under cutting pressure. Second, its poor thermal conductivity traps intense heat right at the tool tip, melting your edge away. The solution starts with the tool. You need an ultrafine green carbide substrate for wear resistance, a PVD coating like a LCRN for thermal stability, and the right geometry. It's a three-dimensional balancing act between sharpness for clean cuts and strength for durability. Forget guesswork. Set your speed between 80 and 150 meters per minute, and you'll feel equal to the pitch. But the real secret is in the depth of cut. Use a progressive, layered approach to manage cutting forces and prevent work hardening. This is non-negotiable. High-pressure internal cooling. It's not just about temperature, it's about forced chip evacuation. Without it, chips will scratch your perfect thread surface and cause premature tool failure. Internal and external threading are worlds apart. Inside a hole, you battle poor rigidity and chip evacuation. The solution? Stronger tool holders, modified parameters, and that high-pressure coolant becomes your lifeline. Let's talk about a real-world fix. A client had a 30% leak rate on 300 for stainless steel NPT threads. We diagnosed micro cracks from work hardening. Our fix: a specialized OCRN coated tool, an optimized cutting path, and precision cooling. The result? Leakage dropped to under 0.5%. For small diameters and deep holes, standard tools fail. We use solid carbide thread mills for maximum rigidity, custom tool holders with guide rings, and a unique segmented retraction programming technique to break chips automatically. Precision doesn't stop at the machine. It requires a system. We use in-process probing for real-time compensation and final inspection with thread gauges and CMAs. This end-to-end quality control is what guarantees batch consistency from the first part to the 10,000th. Mastering stainless steel threads is about transforming knowledge into action. At LS Manufacturing, we don't just sell parts. We partner with you to build your competitive advantage. Upload your drawing to our website now and let our experts provide you with a free quote and a custom solution within 24 hours.